would you move a pet to its new home? Well, that depends on what kind of pet it is, how big it is, and how far you have to travel. Most importantly, you'll want to keep it safe, secure, and healthy during the trip home. Still, it would be best not to overdo things. But what if your pet is a little bit bigger?
NASA Launch Services Program must answer the same sort of questions before every launch. Hi, I'm Martha Breland, and I work in the Launch Services Program, or LSP for short. Today I'm going to show you how NASA resolves many challenges when preparing to launch one of our spacecraft to its new home, safely, securely, and in perfect condition.
NASA spacecraft, like your pet, can be as small as these CubeSats, which are only slightly bigger than a Rubik's Cube and weighs less than 3 pounds. Hundreds of these nanosatellites could fit onto a single Pegasus launch vehicle, one of the smallest rockets in NASA's fleet. Or they can be a large spacecraft like this, tracking and data relay satellite. Getting ready for a NASA mission takes a lot more than just selecting the right launch vehicle to carry the spacecraft to its destination.
To help explain how the Launch Services Program matches a spacecraft with the right launch vehicle, I've asked my friend to show you around.
Hi, I'm Joshua. I'm an educator for NASA at the Kennedy Space Center. Just like it's necessary to plan and make decisions on how to properly transport and care for a new pet, NASA and the scientists who design and develop spacecraft must also make important decisions to make sure that the satellite and the rocket are compatible. It typically takes 3 or 4 years, and maybe up to 10 years of careful planning and engineering before launch. Here's someone from LSP that knows what it takes to do this awesome job. Hi, Elena.
Hi, Josh. Hi there. I'm Elena McGee, and I work in the Launch Services Program as an engineering project manager. NASA science missions are typically chosen using 2 primary methods. The first is a directed mission. NASA headquarters determines specific goals and requirements for a mission and then directs a particular NASA center to implement the mission. The second way that NASA chooses science missions is through a competitive peer review process known as Announcement of Opportunity, or AO.
AO proposals are typically put together by a team of skilled people at NASA centers, other government agencies, educational institutions, and small industry.
A scientist called the Principal Investigator, or PI, leads the AO team and is responsible for developing the objectives and scientific devices for the mission.
LSP also provides spacecraft customers with early analyses and various web-based tools that supply mission designers with performance data for commonly used orbits.
Once the AO proposal mission has been selected, LSP assigns a core mission integration team, or MIT, with the responsibility of managing all integration and vehicle engineering aspects of the assigned mission. The LSP mission manager and MIT must analyze the details of how the rocket satellite system works together while minimizing costs associated with additional development products and mission risks. It is important that the spacecraft design and vehicle selection stay within the budget given in the AO.
Throughout this phase, the LSP mission integration team assists the spacecraft project with the development of the Interface Requirements Document, or IRD. The IRD is a major deliverable that defines the spacecraft size, orbital requirements, target launch data, and science window, and any unique spacecraft design considerations. All of this special knowledge provided by experts in LSP is considered in
Determining the most capable and cost-effective vehicle. Think about it. Why would you buy a 100-gallon aquarium when a fishbowl would do?
Thanks, Elena.
You're welcome.
NASA Soil Moisture Active Passive, or SMAP mission, will collect data from every place on Earth, revealing the amount of soil moisture and whether it is frozen or solid. This information will lead to improved flood prediction, drought monitoring, and enhanced weather and climate forecasts. This particular spacecraft was too large for some of the smaller vehicles, but wasn't large enough to pay for a heavy lift vehicle. The Delta II hadn't flown for 3 years, but fortunately, there were a few critical parts still available. LSP worked with ULS to assemble these parts and prepare this vehicle in order to launch the SMAP mission. This was the perfect solution for this mid-sized spacecraft. If someday you'd like to join NASA on this adventure of exploration, it is important to learn all you can about science, technology, engineering, and mathematics while you are in school. LSP is dedicated to furthering NASA's mission of exploring the unknown and benefiting all mankind. Be sure to check out the SMAP mission on the NASA website.